All right, so tonight I want to talk about the implicit differentiation in calculus. And implicit differentiation is used when it is difficult to solve for y. So now I'm going to start with a simple problem, and I'll explain why in a second. You could solve this for y by subtracting x squared from both sides and taking the square root. Okay, you absolutely could do that. Now, I want to show you kind of why I'm starting with this problem, okay? Then we'll get to one where you'll agree it would be very, very difficult to isolate y, okay? So this one you don't have to use implicit differentiation. On the other one you absolutely do. All right, so here goes. Implicit differentiation is where you are going to go through and take the derivative of everything in the problem. So we are going to take the derivative of this guy, dx, right? We're going to take the derivative of this guy, dx, and we're going to take the derivative of this guy, dx. Now, the derivative with respect to x of x squared is really, really easy. We should know at this point that that is just x squared, or excuse me, 2x. It helps if you get the derivative right, doesn't it? Okay, I'm going to skip this guy for a second. The derivative of a constant is really, really easy. It is 0. Now, we have a problem here. Okay, this is the derivative with respect to x. There is no x in this expression. So really, really easy way to think of this. Okay, really easy way to think of this. This is dx of u squared. Okay, dx of u squared. So if you're familiar with the chain rule, how do we find the derivative of u squared? Well, it's going to be 2u. So we're going to do this the same way. It's going to be plus, right? Copy our plus sign, 2y. But then we have, right? So it's going to be 2u times u prime. It's going to be that inner derivative, okay? Well, when you are taking the derivative with respect to x of another variable, your inner derivative will always be dy dx, or it's d whatever that letter is over what you're taking the derivative with respect to. So I'm taking the derivative with respect to x of y, and so my u prime, my inner derivative, will always be dy dx. What I tell my class, if you're going to be a math major, you want to think about this, ponder it in your mind. But if you just need to be able to pass a calculus class, anytime you do implicit differentiation, you take x and you take the derivative like you've been doing the whole class. You take y, you take the derivative of it just like it's x, so y squared will be 2y, and then plop dy dx next to it. And it is multiplicative. It is multiplicative because we are using the chain rule here. Okay? Now, they ask me to find, I didn't write that, but they want me to find dy dx. So I'm going to isolate this in red. Voila, I found my derivative. So I'm going to subtract 2x. So I get 2y dy dx equals negative 2x. Now, divide by 2y. I get dy dx equals, of course, the 2 over 2 is going to cancel, negative x over y. Dy dx. Okay? So that's how we find our derivative implicitly. That's how we find our derivative implicitly. Now, the reason I chose to start with a really simple problem, if I take this original problem, right, x squared plus y squared equals 1. Okay? And move that x squared over, I get y squared equals 1 minus x squared. And if I take the square root of that, I get y equals the square root of 1 minus x squared. Okay, so I could do all of that, and it's going to be, of course, plus or minus. Okay, now, if I go through and I find this derivative using the chain rule, right, so this would be square root of u. Okay, if I find that derivative, I'm going to get a derivative, and if I plug in, well, let's just go ahead and do it. I'll show you how. Okay, so this is going to be equal to square root of u. Okay, so y prime is going to be 1 over 2 root u times u prime. y prime is going to equal 1 over 2 square root of 1 minus x squared, 1 minus x squared, times u prime, which is the derivative of 1 minus x squared. Well, the derivative of 1 is 0, and the derivative of negative x squared will be negative 2x. And those 2's cancel. And so we get y prime equals 1 over, negative x, right, I got to bring that x over here, over the square root of 1 minus x squared. Now, I have a problem. You say those answers don't match. Yes, they do. No, they don't. They don't match. Yes, they do. Because what did we solve for y? Y is the square root of, oh, that right there is y. So this is equal to that. Okay? These answers are equivalent. So the reason I chose a simple problem to start with is to show you that. Okay? Now, on to a more complicated problem. So that first problem, you did not have to use implicit differentiation. The second one you do. You don't have a choice, because there's no way you're going to solve for y given that you have a first and a third power, and this one, of course, is tied to an x squared. So we want to find dy dx. So how do we do that? Well, we take the derivative of each term. Now I'm going to start here. Derivative of 0 is 0. Derivative of 1 is 0. That's really easy. Derivative of y cubed is going to be negative 3y squared. And I'll always write this in a different color. It just helps me keep up with it. Times dy dx. And remember what I told you. If you take the derivative of something with y in it, you're just going to put that automatically. Okay? Now, derivative of negative 2x cubed is going to be negative, right? 2 times 3 will be 6x squared. We don't add on anything to this because we are taking the derivative with respect to x. Now, this guy here is special because it is a product. You have to use the product rule, okay? Because you have x squared times y. So this is my a, this is my b. Recall the product rule. Y prime is a prime b plus a b prime, right? That's our product rule. So a prime is going to be 2x times b, so times y, plus a x squared, b prime. Well, what's b prime? What's the derivative of y? Well, the derivative of y is just 1 because the derivative of x would be 1. But it's going to be 1 times, because we took the derivative of y, dy dx. Now, let's get everything that doesn't have a dy dx over to the right. So we're going to get x squared dy dx minus 3y squared dy dx stays on the left. And then this guy and this guy move over to the right. So we get 6x squared minus 2xy. Cool. Now we are going to factor out dy dx. So we get dy dx times x squared minus 3y squared equals all this stuff over here. Okay? Now, divide by this. You get dy dx equals 6x squared minus 2xy over this quantity, x squared minus 3y squared. And that is your derivative. Now, where can that come in handy? Where can that be useful to us? Okay, where can we take that and say, well, what good does that do me? Well, remember, what is the derivative? The derivative is the slope of the tangent line at any given point on a curve. So if you've got some curve and you want to know the rate of change or the slope at that point, you can use it. So let's take one, see what we can do with it. So we've got a curve that looks something like this. We've got x squared y cubed plus x cubed plus y to the fourth equals 5. Okay, just some random. And they want us to find the slope of the tangent line at 1, 4. Okay, 1, 4. So we assume that this graph goes through 1, 4, and they want us to find the slope of the tangent line at 1, 4. Okay, so here's what we're going to do. We're going to find the derivative, and right, we got y in a couple of places would be very difficult to solve for y, so we're going to use implicit differentiation. So, and again, I'm going to start right to left because I know this guy's going to use the product rule. This guy, and this guy aren't. Okay, his derivative is simple, it's 0. His derivative is going to be 4y cubed times, don't forget this part, dy dx. Okay, and he'll be plus. This guy's derivative will be 3x squared. And then this guy, of course, we have to use the product rule. So this is A, this is B, and I need to get what? And I'll write it down for you again in case you missed it. A prime B plus A B prime. Right? Derivative of the first times the second plus the first times the derivative of the second. So this guy's derivative is 2x, and then copy him, y cubed, plus copy A, x squared, and the derivative of y cubed is going to be 3y squared. And of course I have painted myself into a hole here, but that's going to have a dy dx attached to it. Has to have that dy dx attached to it. So I'm actually just going to rewrite this so that it's clear. So it's going to be 2xy cubed plus, and I'm going to go ahead and put this 3 out front. So that's going to be 3x squared y squared dy dx plus 3x squared plus 4y cubed dy dx equals 0. I am going to move my terms that do not have dy dx to the right. So we get 3x squared y squared plus 4y cubed, both with dy dx, and that's equal to, and it's going to be this guy and this guy are both going to be minus. So minus 2xy cubed minus 3x squared. Factor out a dy dx, so dy dx times, and y'all, if you are really good at math, you get bored with me not skipping too many steps. I promise the less steps you skip, the better you get at math. And when you make a mistake, you can find it. I learned many years ago as a student, the more work I showed, the happier my teachers were, and the better I got at math faster. So I urge you to get over your laziness and show your work. It is a huge help to you as a student. All right, so now we're going to divide by all of this quantity here. So we get dy dx equals, and we get negative 2xy cubed minus 3x squared over 3x squared y squared plus 4y cubed. Okay, so that is the derivative, but they didn't ask for that. They asked for the slope of the tangent line at 1, 4, and you've got to remember that this is simply an x and a y value. Okay, And so what we would do to finish this problem up, and this is where it gets kind of messy, is you would sub x equals 1 and y equals 4 into this expression. Okay? Whatever number that gives you, that would be your answer. Okay? So you'd have to dig out, I would personally dig out my old pocket brain here, right? Y equals 4, y to the third, right? So that'd be 64, right? Then times 1 times -2, and then, yeah, it would be kind of messy. Not too bad, but, I mean, I guess you could do it. But anyway, but you would find a value up here, find a value up here, and that fractional value would be your slope, okay? And that's it. That's implicit differentiation. And implicit differentiation tends to be used in a concept called related rates. It tends to be used in related rates. And that's basically application problems that have a rate of change listed in them. And I'll do a separate video for related rates. But you got to have implicit differentiation usually before you can do related rates. Okay? So if you have any questions, leave them in the comments. Please like and subscribe, and I appreciate all your support. Thank you, guys.